Okay, quiet please. Quiet. Okay, this is the second day out of the same section in the book. Right, this time we are doing some special cases of lines. So graphing linear equations. So they introduce a new form of a line. Well, it's actually for us, it's the first. Because although you may have learned in the past slope-intercept form, y equals mx plus b, in this book so far, this is the first form of a line, equation of a line that we got to, and it's called standard form. Standard form is when the x and the y term are on the left, and there might be a constant on the right. You know, it's always given by capital letters, ax plus by equals c. And the a, b, and c's are real numbers. So again, why would we consider that to be linear? I just said it in the homework. Believe there will be questions on the test like, what is it that makes an equation linear? Yeah, the exponents are 1, right? We know then that the graph will have a shape of a straight line. Okay. So special cases, right? If the a, the coefficient of the first term equals 0, then there is no first term, right? 0 times x is just going to be 0. So all you have left is, make sure I got that going. All you've got left is by equals c. How would I solve that for y? Divide by b, right? That's why we do this literal equations in the last unit. So it's y equals c divided by b. And c over b are real numbers. So basically it's just saying y equals a number, a constant. Okay, well what would happen if the b equals 0? If the coefficient on the y is 0, then there is no y term anymore. And all you get is ax equals c. How do you solve for x? Divide by a. X equals c over a. Right? So those are two particular forms of a line. Okay. Which are called, well, graph x equals -1. Okay, so x equals -1. If I make a table of values, the only x value that I can put in is -1. And we don't know anything about the y value. So basically we want the set of all points that have an x coordinate of -1. So how do I graph x equals -1? Let's say if I go right there, is that got an x coordinate of -1? How about if I go right there? Does that have an x coordinate of -1? Okay, if I keep going up like this, do I keep having an x coordinate of -1? Okay, every one of those is 1 to the left of the center line. So it has an x coordinate of -1. So in fact, we could do the points in between, right? We could put infinitely many points on that line. Okay, that's a 0 classwork, okay? And a call home. Okay, so what kind of a line is that? It's a vertical line. So when x equals a constant, you should get a vertical line, right? A line straight up and down. Okay, what do you think you're going to get if you have y equals a constant? Right? It's going to be a horizontal line, okay? So what that's telling you is we want the set of all points that have a y coordinate of 2. Okay, so where do you find that? Y coordinate of 2 means you're 2 above the middle. So we want all the points that are 2 above the middle, which would be this point, and, you know, I could put infinitely many points on that line, but ultimately when I connect them, like we learned to do in the last lesson, they are a horizontal line. Okay, now, kids get confused about this all the time, like which one is which. In your calculator, go to y equals, right? Go to y equals and put in y equals 2. and then look at the graph. And you can see it's a horizontal line. So if you're confused, let's say if you got like x equals -1 like on the last one, and you're not sure because you don't have an x equals button, just try the y equals, which you've got, right? And you know that the x equals will be the other, right? Whatever, one is horizontal and one is vertical. What's your first problem? Okay, so one way or the other, you got to keep straight which one is vertical and which one is horizontal, right? It's not going away for about the next 3 years. So here's the equations of horizontal and vertical lines, right? Y equals b, which is just a constant, where b is the y-intercept, and it's a horizontal line going through that point, 0b. X equals a, that's the x-intercept, the vertical line going through that point. So horizontal versus vertical. Okay, so try these two. Graph, y equals 2.5 on your paper, not in the calculator, on your paper. Right, so what kind of a line is it going to be? Horizontal or vertical? Horizontal because it's y equals. And what's the one point you know it goes through? It goes through a y-intercept of 2.5, which is halfway between 2 and 3. So draw a horizontal line through there. Right, should be easy. Okay, try this one. Graph x equals -4. And you don't have an x equals button on the calculator. Okay, what kind of a line is it? X equals.
It's a vertical line.
It's a vertical line, right? I can see now we're going to have a non-calculator portion of this next test. Okay. So what's the one point you know it's going to go through? The x-intercept of -4, right? So right there. So I'm going to draw my line. Now, if you're doing this on your own paper, let's say it's on a test, and you do your axis like that, and then you draw a line over here like that, partial credit, because I have no idea where that line is. If you go 1, 2, 3, so I can see, okay, you got it 4 to the left, that's full credit. But unless you show how many units to the left it is, that's not exactly right. Okay, got to be more careful than that. Okay, last, graph the function y equals -1/2 x plus 4. But this time they're telling us the domain is x greater than or equal to 0. And then identify the range. Well, in the homework from last night, how did we graph a straight line? First we solved for y, and then what did we do? We did a table of values, and we plugged in some x values, okay? What this statement right here is telling us, x greater than or equal to 0, it's telling us that you have to use x values that are greater than or equal to 0. They're limiting the domain. You can't just pick any x values now. So what's the first point you want to pick to put in our table of values? How about 0? I'd always pick, if it says greater than or equal to 0, then use the 0. Okay, and now, what were you going to say, Callie? What were you going to say?
Oh, we're just going to say anything that's greater than 0.
It's greater than 0, and what else? How about we make it so it's divisible by 2, since it's being multiplied by 1/2? So how about if I pick the next 4 even numbers? 2, 4, 6, and 8. Okay, and plug them in one at a time. If x equals 0, what does y equal? If I put in a 0 here, it equals 4. Right? If I put in a 2, what does y equal? That's negative 1/2 times 2. Right? That would be negative 1 plus 4 is 3. Okay, how about at 4? 2, how about at 6? 1, how about at 8? 0. So we put 5 values in because at this point that's still what we're doing. And we're going to graph this line by plotting those 5 points. 0, 4, 2, 3, 4, 2, 5, 1, and 6, 0, or 8, 0, sorry. We should have said 6, 1, 8, 0. Okay, then what do we do with those points? Draw a line through them, right? Is that line going to go infinitely left and right?
Yeah.
No, because it said x is greater than or equal to 0. So where is it? Where is it that x is greater than or equal to 0? Infinite to the right. It's got to start at one spot. Right? It's got to start at one place, so it's got to start here, but it just goes to the right. Okay. Last question. Then what is the range? Okay, what's the highest y value you see on that graph? 4. Okay, but understand it's not just made up of those 5 points. That line is made up of infinitely many points. So I can't describe it by just listing a bunch of points. Like they gave the domain as x greater than or equal to 0, we have to say that the range is y is less than or equal to 4. Right? It'll go infinitely down. Right? But it includes more than just the points we plugged in. Okay, so y is less than or equal to 4. So try to do the same thing with that one. Okay, so the graph, you should have picked values of x that were less than 0. Substitute them to get some values. Those are probably the easiest 5 values you could have had. Plotted them and connect them with a line. But does the line go infinitely both directions? No. It stops at the y-axis where x is less than or equal to 0. So what would we say is the range of that?
Y is less.
Y starts here and it goes up. How would you describe that? Greater than or equal to 0. 1. Right? When we plug in 0, we got 1. It looks like the y value started at 1 and they went up from there. So write down the homework. Solving equations for y.